In the surface water section, we have the unsupervised clustering script. The algorithm name is water detect. So do read the paper. They have a Python implementation as well. So if you just want to download data on your machine and run this, you can use their Python library. I worked with the author of this paper and implemented an Earth Engine version. So you can run this water detect algorithm in Earth Engine. So this is how it works. Let's see. The data here, we are looking at Sentinel-2. You create a composite. We have this function for masking clouds where you take the metadata and remove the pixels which might be cloudy. We mask them, and then you create a median composite. This results in a better composite because you're not looking at the cloudy pixels. You're just looking at pixels which are cloud-free. Once you have your median composite, we compute some indices. We use NDWI, MNDWI, and we select the SWR2 band. Again, this technique allows you to use as many bands that you want. So you can have 5 different indices that you can use. Since our interest is water, we can say these 2 indices are water indices. I want to use that. And SWR2 bands also is useful for detecting water. So I'm going to use a combination of these 3 bands. So we selected 3 bands. You create a stacked image. So now we have a 3-band image with the SWR2 band, NDWI, and MNDWI. And we take a sample of 1,000 pixels. So it's from this image, let's take 1,000 pixels, and that becomes our training data. So you can see our training data looks like this, that we have 1,000 points, and each point I have the value of the SWR2 band, MNDWI, and NDWI. This one is our table. So this is what we've generated so far. We have 1,000 rows and 3 columns. You could also add any other index that you want. And now we say, let's use this Cascade K-means clusterer and say train a cluster on this data and detect clusters between 2 to 10. We need to initialize this cluster and say, this data set has between 2 to 10 clusters. You'll find the most optimal number of clusters that is, will separate this data. And we'll train this using this training data. And we have a clusterer. We say, now go and cluster all the remaining pixels. So once it's trained on this data, we'll take any input value and say, which cluster does it belong to? And it'll cluster them into separate value. If you visualize the cluster image, so this is the cluster image. If you have all these different classes and you want to visualize it, Earth Engine provides you with this really nice function called random visualizer. Just assign a random color to each class and visualize this. So this is a source image, and this is the clustering output. So I'm going to show you what that looks like. So based on these 3 pixel values of 3 indices, it has determined that all these pixels which are having the same color, they belong in the same cluster. So below is the image, and using those 3 pixel values, it has grouped them into different classes. So all that is pink is the same thing. All that is green is the same thing. All that is brown is the same thing. Normally in unsupervised clustering, you would go and say, oh, this is vegetation, this is urban. You will label them manually. But here we can apply our NDWI technique. And again, this gets advanced here. We are using reducers, something called a group reducer, to compute the mean of each cluster. So we do a reduce region and say, within this region, give me the mean of each cluster. And from that cluster, we use a max reducer. Again, it's a little advanced reducer where it's a 2-input reducer. It'll find out the cluster having the highest NDWI. And it will tell you that this is the cluster number which has the highest NDWI. And finally, we say water is cluster equals to that cluster number. So if we had 5 clusters and we figured that number 4 is the one which is highest NDWI, we just say select all pixels where the cluster is equal to this, self-mask it and see it. So now we take this data and we say show us the water. So from an image, we sampled 1,000 points, sent it to the clusterer, looked at the average NDWI, figured out the cluster having the highest NDWI, and we selected that cluster, and that will be the water. So you can now see all the polygons of water. And so we have suddenly detected all the water. And you can see it doesn't have this salt pepper noise because it's a clustering, right? It's grouping pixels together. Without knowing any threshold, without knowing anything about the land, we get a pretty clean output generated from this. We tested this on 100 cities when I first developed this, and I was very impressed with the results compared to other algorithms. So again, that's why it's my favorite method when I want to try water detection. It's completely automated, and you can apply this on any cities. If you have snow, you need to separate out snow somehow. So use an NDSI to separate out snow, because otherwise NDWI will get confused between water and snow. Otherwise, if there's no snow, I think it performs quite well.